Hi, Dr. Biology here, and this video looks at how do you measure the rate of transpiration, so mainly using a potometer. So before you do that, if you haven't already, please do check out my other videos. So I've done cohesion tension theory, I've also done the rates of transpiration and looking at translocation in the phloem. So how do we measure the rate of transpiration? Well, you would use one of these things called a potometer. So in terms of laboratories, most laboratories have ones like the top two, and you can see the bottom one is a more traditional potometer. So the first thing you're going to need to do is cut a shoot of a plant. When you cut it, you need to make sure that you cut it underneath water because you don't want any air columns to get into the xylem. So a popular question is this: explain why the shoot needs to be cut underwater. And it's to prevent air entering the xylem and interrupting the water flowing in the column, stopping the transpiration. So here we have a potometer, and as you can see, the potometer is a completely sealed system. Okay, you've got water and you've got the reservoir where you can fill the actual tube, and then within the tube you've got an air bubble, and I'm going to talk about how you would get that air bubble in. So one of the key things though is that obviously you're measuring the rate of transpiration over time. Okay, so you can see transpiration occurring, and what will happen is that the bubble will move over a set amount of time, and that's what you're going to be measuring. So a key question they sometimes ask is, why does the apparatus need to be water and airtight? It's because water can only leave by evaporation through the stomata in the leaf. So you're making sure it's completely sealed. So you would also use grease as well. So around the shoot you'd use grease to stop water getting in, but it's a completely sealed system. So the only place water vapor can escape is through the leaves. So how do you assemble a potometer? Well, would they ask you this? I don't know whether they would ask you the method itself, but it's important you know how it's done. So as I said to you earlier, you make sure that you first, before you stick in the chute, you've got to actually submerge the whole apparatus in a beaker of water. Then you insert the chute underwater. Then you need to make sure it's watertight and airtight. You need to then dry the leaves. Okay, so you can't immediately measure the rate of transpiration. You've got to dry the leaves or allow time for the chute to acclimatise. You'd shut off the tap to the reservoir just above my head there. Okay, and then remove the end of the capillary tube from the water beaker until you get one air bubble being formed. And then you can put the tube back into the water, record the position of the air bubble, use a stopwatch to record time. So it could be for 1 minute, it could be for 15 minutes, it could be for 24 hours. And you record the distance moved per unit of time. And the key thing is you're changing one variable at a time and keeping all other variables constant. So what kind of calculation may they ask you to do? Well, this is a very popular one. So I've actually got an exam question here. So they ask you to work out, it says, calculate the rate of water uptake by the chute in this experiment. So what you need to do is you need to have pi r squared times the distance travelled, which is then given in millimeters cubed, in this case per hour. So how would you go about doing this question? Well, let's have a look. So if we look at this experiment, it says the air bubble moved 7.5 millimeters in 15 minutes. The diameter of the capillary tube was 1 millimeter. Calculate the rate of water uptake by the chute. It says give your answer in millimeters cubed per hour, so we only know the data for 15 minutes, and it does say show your working, and it tells you the area of a circle is found using pi r squared, which is very useful. So what you're going to do is per hour, 7.5 times 4, so that's 30 millimeters per hour. The radius is the diameter divided by 2, gives you 0.5 millimeters. So what we can do is we can then work out pi r squared. So 0.5 squared times pi gives 0.79 times the distance traveled in 1 hour. And that will give you your answer, which is 23.7 millimeters cubed per hour. Okay, here's some more questions. What I would like you to do, please, is to pause and we'll go through them in a minute. Describe how the students would have returned the air bubble to the start of the capillary tube. Well, you open the tap of the reservoir, so you don't have to remove all the equipment. You just open the tap and you add water from the reservoir. Give 2 precautions the students should have taken when setting up the potometer to obtain reliable measurements. Well, I think we did discuss that, and we said you would cut the chute under the water, or you seal the joints or make sure it's airtight. You dry the leaves, insert into the apparatus underwater, make sure there's no bubbles present, shut the tap, note where the bubble is at the start of the experiment. So there's lots of different things you could include. If they ask you that question in an exam, those are all the potential precautions there. So C, a potometer measures the rate of water uptake rather than the rate of transpiration. Give 2 reasons why the potometer does not truly measure the rate of transpiration. So this is a pretty good question. Well, basically, not all the water is going to be evaporated out of the leaf. You need to know that water is going to be used for other processes. So it's used to support for turgidity or support, or it's used in photosynthesis, produced in respiration, so there'll be more water vapor there. And also if the apparatus isn't sealed, so it may have leaks. So that's a pretty good answer there as well. Next question. So the student wanted to calculate the rate of water uptake by the chute in centimeters cubed per minute. What measurement did she need to make? So again, I'd like you to pause and we'll go through it in a minute. So you need to know 2 things. You need to know the distance moved by the bubble in the amount of time, in a particular time, but also you would need to know the radius or the diameter. I would put the diameter of the capillary tube so that you could then work out the area of the tube. I hope you found that useful. Please do subscribe to Dr. Biology, and there'll be more videos coming soon. Take care. See you soon.